Okay, this is a video on B2, transformations of exponential functions. So we're graphing exponential functions, and then we're also applying some stretch vectors and some relations. Okay, so here we have some base functions, like y equals 2 to the x, y equals 5 to the x, and we just want to graph what these guys look like without any transformations being done to them. We did this in B1. So just if we had to graph this function, you could make a little table of values if you wanted to, and just check, okay, when I sub in 0 for x, what does y equal? So 2 to the power of 0 is 1. So I know I'll have a y-intercept of 1, which is actually true for all of these functions because anything to the power of 0 is 1. So they're all y-intercept of 1. And then we just check what's happening on either side of the y-axis. So let's see, if when x equals 1, 2 to the power of 1 is 2. So we'll have a point there. We could check the next point when x is 2. So 2 to the power of 2 is 4. 4, so we'll have a point here. And we could even check like a negative 1. So if we sub in a negative 1, 2 to the negative 1 is a half. So I know at negative 1 it's down here at a half. So what's going to happen is I'm going to get closer and closer to the x-axis, and then when I go to the right here, I'm getting bigger and bigger. So what's happening is right along the x-axis, I've got an asymptote where my line's getting closer and closer to, but it's never going to touch it. So I have an asymptote at y equals 0. Because it's right along this line that y equals 0. And that's true for all of my functions. So this is the graph of y equals 2 to the x. So y equals 5 to the x would look extremely similar, but it would just get steeper faster. And then if I look at these two graphs, 1/2 to the x and 1/4 to the x, turns out they're just going the other way. So they're from left to decreasing functions. So 1/2 to the x would look something like this. So same y-intercept, same asymptote, but we're starting big and getting small. And then 1/4 to the x would just be even closer to the y-axis there. So those are like our base functions. And we can have any base, 2, 5, 10, 3, 4, whatever, a half or a third, doesn't matter. Any of those, you should kind of know what their graphs look like. And then once you know that, we're going to apply some transformations to our graph. Okay, so here's what our equation could look like. So I put a b here just to represent whatever the base function is. So that could be a 2, a half, a 3, it could be any number for this base function. Okay, so then if we have a number in front of our base function, like if we had y equals 2 to the 2 times x, something like that, that would be our a value. And what our a value does to the graph is it's going to be our vertical stretch and compression. So if a is a big number, like 2, 3, 4, 5, 6, it's going to stretch it. And if it's less than 1, like a half, a quarter, a third, it's going to compress it. And then also if a is a negative value, that's going to cause a reflection in the x-axis. So it's going to cause our graph to get flipped over the x-axis. K does exactly the same thing, but horizontally. It's the horizontal version, and it does everything by a factor of 1 over k. It's kind of weird. So it's a horizontal stretch or compression, but it's like the opposite. So it's a horizontal stretch if k is like a half, a third, a quarter, whereas it's a horizontal compression if k is like 2, 3, 4, 5, 6, because it's actually by a factor of 1 over k. Okay, then is our horizontal translation, so it's going to shift our graph left and right. So what happens is the opposite of what we think. If we have something like x minus 3 in the bracket, this 3 is actually a positive value since there's already a negative in there. So a negative 3 there would actually shift our graph to the right. Okay, and then finally C, that's our vertical translation, so that's going to shift our graph up and down. And C is really special because C also tells us the equation of our asymptote. So our asymptote is usually at y equals 0, but it will be now at y equals whatever C equals. So let's try one. F of x equals 3 to the negative plus 1. So let's check it out. This negative right here is going to cause a reflection in the y-axis. And this plus 1 right here is going to shift our graph up 1. So we've got two transformations happening to our graph. So first I'll graph the original, 3 to the x, which I know goes through a y-intercept of 1, and I know is an increasing function like this. So this is my graph of y equals 3 to the x. So now if I want to draw my transformed graph, well, first I'm going to have a reflection in the y-axis. So that means my graph is going to end up looking like this. That's my reflection in the y-axis. But then also my whole graph is actually getting shifted up 1. So the graph is actually going to look like this. Just like that. So I'll just get rid of this dotted line here. And this is the graph of y equals 3 to the negative x plus 1. So this graph will have a y-intercept at 2. And we'll have an asymptote at y is equal to 1. So right along here. And that's our graph. Okay, let's try the next one. G of x equals 2 to the 1/2 x plus 3 minus 4. Okay, a lot of transformations going on there. So if we first want to graph our base function is this guy right here, the one that's got the exponent on it. So that's 1/2 to the x. That's our base function. So we know it's going to have a y-intercept of 1, and it's going to go in this direction. So this is our base function of y equals 1/2 to the power of x. Okay, so if we're going to transform it, we can see right here that we've got a vertical stretch of 2. Our graph is going to shift to the left 3, and our graph is going down 4. Okay, so that's all the stuff that's happening. If we want to quickly find our y-intercept, because I don't know, it's just nice to be able to plot that, we can sub a 0 in for x. So we have 2 times 1/2 to the 0.3 minus 4, and we just solve that. So 2 times 1/2 to the power of 3 minus 4. So 1/2 to the power of 3 would be 1/8 minus 4. So that would be 2/8 minus 4. And 2/8 would actually be 1/4. And then if I made that have a denominator of 4, I got 16. So that would be negative 15/4 for my y-intercept. One, two, three, 4. Okay, so that's going to be somewhere in here. So I know my y-intercept is going to be there. And then I also know that my asymptote is going to be wherever c is at y equals negative 4. 1, 2, 3, 4. Yeah, so I'm going to have an asymptote right at negative 4. Then I also know I'm not reflecting it, so my graph's going to look like the exact same shape, but just be like maybe a little steeper since I have a vertical stretch of 2. Okay, so just to rough sketch this, first I know that since it's getting, all my y values are getting stretched by 2, I know it's going to look something like more like this. And then I know that every point is getting shifted to the left 3 and then down 4. So then I also kind of know, it's something like that, because it's actually getting shifted over. So that would be like a rough sketch of what our graph would look like. Okay, so I hope that helps slightly. It's a little tricky, but you just want to deal with transformation at a time and just give it a rough little sketch. The important things that you sketch are the y-intercept and the asymptote, and then it's just important that you get the right direction of the graph, like that's this way versus like this way or something. So just kind of the right direction and shape of the graph. Good luck.